We take for granted that death means the end. Complete erasure. When your heart stops beating and your neurons cease firing, you vanish from existence. The information that constituted your thoughts, your memories, your personality, all of it simply disappears. Everyone knows this. It's the most obvious fact about mortality. But here's the strange thing. This familiar certainty may violate the fundamental laws of physics. The universe, as far as we can tell, has no mechanism for destroying information. Not a single physical process permits true erasure. Fire doesn't destroy, it transforms matter into ash, smoke, heat, and light. Evaporation doesn't erase, it redistributes molecules from liquid to gas. Even the most violent cosmic events, supernovae, galactic collisions, the grinding pull of gravity, only scatter and reorganize. They never truly delete. Yet we assume biological death accomplishes exactly this impossible feat. Consider for a moment what happens when you delete a file from your computer. It feels gone, vanished completely. But the magnetic patterns on the hard drive persist until overwritten, and even then, forensic recovery can often retrieve the data. True digital erasure requires extraordinary effort, multiple overwrites, specialized tools, deliberate destruction. Human engineers had to work quite hard to create a delete function that actually deletes. Now consider this. The universe has no such function. It has only scatter into impossible-to-recover form. If even computers, human inventions, resist true erasure, what about the cosmos itself? What about the physical processes that govern matter, energy, and the flow of time? The question is whether the universe's laws actually permit information to be destroyed. Not scrambled, not dispersed, not transformed, destroyed, meaning the distinction between one configuration of matter and another vanishes without trace. As we shall see, physics has rather strong opinions about this, and those opinions have profound implications for what death is and isn't. For 3 decades, the most extreme objects in the cosmos appeared to prove that oblivion was real. Black holes, regions where gravity becomes so intense that not even light escapes, seem to be nature's ultimate information shredders. Throw a book into a black hole, and all record of its contents vanishes forever. Or so brilliant physicists believed. If black holes could destroy information, surely biological death could too. But what if that assumption was wrong? In March 1974, a physicist made a calculation that sparked a 50-year war. The calculation was rigorous, the implications were heretical, and the resolution transformed our understanding of reality itself, with consequences extending far beyond distant cosmic objects into the most intimate question we face. What happens to the pattern of information that is you? The universe, it turns out, may be in the perfect record-keeping business, not the forgetting business. This changes everything. Picture the universe as an infinite accountant who records every transaction with perfect accuracy, but whose filing system is so chaotic that retrieving any specific entry is impossible. Every event, every particle interaction, every thought, every moment of existence gets logged permanently. The books always balance. Nothing vanishes without leaving its mark in the cosmic ledger. But the accountant uses an encryption scheme so complex that accessing past entries becomes practically impossible. This is how information actually works in our universe. The records exist, perfect, complete, eternal. Recovery, that's a different matter entirely. In 1974, a calculation revealed that black holes aren't perfectly black. They emit radiation through quantum processes at their event horizons, virtual particle pairs, where one particle escapes whilst the other falls in. Over timescales that make geological ages look like eye blinks, black holes slowly evaporate. Eventually, they vanish completely. The scandal wasn't the radiation itself. The scandal was what appeared to happen to information. When you throw a book into a black hole, the hole's mass increases slightly. That's all it remembers. Total mass, rotation rate, electric charge. It doesn't remember the book's title, its contents, the specific arrangement of ink on paper. When the black hole eventually evaporates via this radiation, only featureless thermal energy remains. The information about the book, the specific quantum state that distinguished it from every other possible book, appears to be erased forever. This violated quantum mechanics' most sacred principle, unitarity. Quantum evolution must be reversible. Given complete knowledge of a system now, you should be able to calculate its state at any past or future moment. Information cannot be created or destroyed, only transformed. The mathematical operators describing time evolution are unitary. They preserve the inner products between quantum states, meaning distinguishable states remain distinguishable. This isn't a nice principle. This is the foundation that makes quantum mechanics coherent. If unitarity fails, the equations break. Probability stops summing to 1. Energy fails to conserve. Causality collapses. You cannot violate unitarity without rendering physics nonsensical. Yet black holes appear to do exactly that. Initial state, book plus black hole. Final state, featureless thermal radiation. The two states are indistinguishable. Information destroyed. Pure quantum state becomes mixed state. Impossible, quantum mechanics insisted. Inevitable, the calculation showed. The physics community split into warring camps. General relativists, those who studied gravity and spacetime, accepted the calculation. Information is destroyed in black holes. Quantum mechanics requires modification. Particle physicists, those who studied quantum fields and fundamental interactions, rejected this conclusion. Information must be preserved. The calculation must contain a subtle error. Find the escape route. The stakes were existential for physics itself. If quantum mechanics was wrong, centuries of successful predictions collapse. If general relativity was wrong, our understanding of gravity fails. One of physics' foundational pillars had to give way. On February 6, 1997, the conflict became official. Prominent physicists made a public wager, an encyclopedia that information is destroyed in black holes. The prize itself was telling, an encyclopedia from which information can be retrieved at will. The irony was not accidental. For 30 years, brilliant minds attacked the problem from every angle. Some propose that information leaks out subtly through quantum correlations in the radiation, but the calculations suggested otherwise. Others argued that remnants remain after evaporation, but these led to problematic infinities. Still others suggested information simply vanishes, but this meant rewriting quantum mechanics. The universe, meanwhile, continued its perfect bookkeeping, indifferent to human confusion. Watch what happens when you burn paper. The matter doesn't vanish, it transforms into ash, smoke, heat, and light. Every atom that was paper still exists, just redistributed. The information about the paper's configuration persists in correlations among these products. The smoke particles' trajectories, the ash molecules' positions, the thermal photons' frequencies, all carry data. Approximately 10 to the 25th power particles participate in burning a single book. Each trajectory encodes information. The quantum state is preserved. Similarly, when ice melts, H2O molecules don't disappear. They reorganize from crystalline to liquid structure. The transformation is thermodynamically irreversible in practice. You won't see the puddle spontaneously freeze back into its original ice cube shape, but the information allowing reconstruction persists in the precise positions and momenta of molecules. Given perfect knowledge, impossible to obtain, you could work backwards. This is what physicists mean by information conservation. Not that we can practically recover the original state, that the universe maintains enough detail in its quantum state to distinguish between different histories. But black holes seem different. The radiation coming out appeared to have no correlation with what went in. Featureless, thermal, random. The ultimate information shredder. The cosmos is one exception. If true, this would prove that oblivion exists, that true endings are possible, that patterns can be erased so completely that the universe itself forgets they ever existed. As we shall see, the universe had other plans. The resolution required reconceiving reality itself, questioning whether three-dimensional space is even fundamental, whether information might be encoded in places we never imagined, whether the universe's architecture is stranger than anyone guessed. Black holes didn't destroy the information. They hid it so cleverly that finding it took 50 years of brilliant physics and a revelation about the nature of existence itself. Before we can understand why the universe refuses to erase information, we must understand what physicists mean by information. It's not what you think. In everyday usage, information means knowledge, meaning, data, the words in a book, the contents of a conversation, the semantic significance of a message. In physics, information means something entirely different and far more fundamental. The complete specification of a quantum state that distinguishes it from all other possible states. Think of it this way. Two books with different texts represent different arrangements of matter, different configurations of atoms, different patterns of ink molecules, different quantum states. The universe must preserve the distinction between them, even if practically recovering which was which becomes impossible. Information is distinguishability itself. Consider shuffling a deck of cards. After thorough shuffling, the original order seems lost, but it's not destroyed. The information persists in the specific sequence of shuffled cards. Given that sequence, you could theoretically work backwards to deduce previous orderings. The shuffle scrambled the information, made it practically inaccessible, but preserved it completely. Now scale this to the quantum realm. A quantum state contains all information that can potentially be known about a system: energy, momentum, spin, position, probabilities, everything. When systems interact, their quantum states become entangled, correlated in ways that no classical description can capture. But through all these interactions, all these entanglements, all these transformations, one principle holds absolutely. Distinguishable states remain distinguishable. This is unitarity. The mathematical operators describing time evolution are unitary. They preserve inner products between quantum states. This isn't arbitrary. It's the structure that makes quantum mechanics mathematically consistent. Unitary evolution means if you know a system's state now, you can calculate its state at any past or future time. The universe computes forwards and backwards with equal facility. Watch billiard balls collide. Given their positions and velocities after collision, you can calculate exactly where they were and how fast they were moving before impact. This is time reversibility, a consequence of unitary evolution in classical mechanics. Quantum mechanics works similarly, just with probability amplitudes instead of definite trajectories. Violate unitarity and probability stops summing to 1. The chance of all possible outcomes must equal 100%. That's just logic. But non-unitary evolution breaks this. Suddenly, probabilities don't add up. Energy fails to conserve. The equations become nonsense. The universe would lose mathematical coherence. So information must be preserved, not as a philosophical preference, as mathematical necessity. The critical distinction, as we shall see, is between information being lost and being scrambled. When you burn a book, the information about its contents doesn't vanish. It becomes encoded in the precise trajectories of smoke particles, the molecular patterns of ash, the correlations among emitted photons. Every one of approximately 10 to the 25th power particles involved carries data. As one physicist explained, if you could reverse the motion of every particle involved, accounting for every interaction, the book would reassemble. Impossible practically. We lack the precision, the computational power, the ability to track that many particles, but permitted fundamentally. The laws of physics allow the reconstruction even whilst making it absurdly impractical. This is what the universe does. It scrambles information into environmental correlations whilst preserving it completely. We mistake our inability to recover information for its destruction. The universe makes no such mistake. The no-hiding theorem proved this rigorously in 2007. If information becomes inaccessible in one part of a system through quantum decoherence, it must appear somewhere else, in the environment, in correlations, in the larger quantum state. It cannot simply hide. It cannot vanish into quantum correlations without being recoverable in principle. The universe has nowhere to stash information permanently. No known physical process fundamentally destroys information, scrambles it absolutely, disperses it constantly, makes it practically irretrievable routinely, but destroys it? Never. Except, apparently, black holes. Or so the calculation claimed. This wasn't physicists being stubborn about a principle. This was a genuine mathematical contradiction between two pillars of physics. General relativity said information enters black holes and cannot escape. Quantum mechanics said information cannot be destroyed. Both theories had been tested extensively. Both appeared correct. Something had to give. The universe doesn't care about our theoretical disputes. It does what the equations say. The question was, which equations correctly describe reality? As we shall see, the answer required recognizing that reality itself might not work the way it appears. That three-dimensional space might be a projection. That information you think is inside a region might be encoded on its boundary. That the familiar world of solid objects in three-dimensional space might be an emergent description of something more fundamental. Information is distinguishability. Unitarity demands preservation. The universe allows scrambling but forbids destruction. These aren't negotiable principles. They're built into reality's mathematical structure. Understanding this transforms how we see everything, including mortality itself. Because if consciousness is information, and information cannot be destroyed, then death isn't what we think it is. The solution to the black hole information paradox came from the most counterintuitive idea in modern physics. Reality itself might not be what it seems. All information in any three-dimensional volume of space can be completely encoded on its two-dimensional boundary surface, like a hologram, projecting 3D images from 2D information. This is not metaphor. This is mathematics describing how the universe fundamentally works. Tilt a holographic credit card and watch three-dimensional images appear. Depth, perspective, multiple layers emerging from patterns on a flat surface. Yet all the information creating that illusion lives in two-dimensional encoding. The 3D experience is real. You see it. You perceive depth. But the fundamental description requires only 2 dimensions. The entire universe may work this way. In 1993, a Dutch physicist named Gerard 't Hooft proposed something radical about black holes. Their entropy, a measure of information content, equals 1/4 of the event horizon's surface area, not the volume. This shocked physicists. Information should scale with volume. The number of apples fitting in a box depends on the box's volume, not its surface. But information capacity depends on area. This seemed wrong, counterintuitive, impossible. Yet the mathematics was rigorous. Leonard Susskind developed this into what we now call the holographic principle. All information in any region of space is encoded on that region's boundary. For black holes, information falling inward is simultaneously encoded on the event horizon. It was never truly inside in any conventional sense. The 3-dimensional picture of matter falling into a black hole is incomplete. The more fundamental description encodes everything on the 2-dimensional horizon. If the information is on the surface, it can leak back out through quantum correlations in Hawking radiation. The paradox dissolves. Information preserved. Unitarity maintained. Quantum mechanics vindicated. Black holes don't destroy information. They scramble it onto their surfaces and slowly radiate it back out, encrypted so thoroughly that practical recovery is impossible, but theoretical preservation is absolute. The universe, it turns out, has better information retention than most bureaucracies, though significantly worse indexing. In 1997, Juan Maldacena provided rigorous mathematical proof through something called ADS/CFT correspondence. A gravitational theory in d dimensions precisely equals a quantum field theory on the boundary in d-1 dimensions. These aren't approximations or analogies, they're equivalent descriptions of the same reality. Like seeing the front and back of a coin. Both real, both valid, neither complete without the other. This became the most cited paper in high-energy physics history, not because it was easy, it's fiendishly complex, but because it revealed something profound about reality's architecture. Think of digital music on a CD. The sound seems 3-dimensional, melody, harmony, rhythm, unfolding in time, but fundamentally it's binary code, 1s and 0s on a flat disk. The 2-dimensional encoding produces 3-dimensional sonic experience. The music is real, the experience is genuine, but the fundamental description lives in fewer dimensions. Your brain does something similar. 3-dimensional visual experience emerges from 2-dimensional retinal images processed into depth perception. You experience solid objects in space, but your eyes receive flat patterns of light. The brain constructs 3D from 2D information. The universe may be the ultimate version of this principle. Mark van Ramsdonk offers perhaps the most stunning image. When you have the right pattern of quantum entanglement, you get spacetime geometry on the other side. It's almost like spacetime is a geometrical representation of entanglement. Take away all the entanglement, and you just eliminate the spacetime. Read that again. Space itself, the 3-dimensional void you move through, the container you've always assumed holds everything, may not be fundamental. It may be what information relationships look like when organized correctly. Space emerges from information patterns the way melody emerges from sound waves. Real. Yes. Fundamental? Perhaps not. This has staggering implications. If the holographic principle is correct, then the 3-dimensional world we inhabit is a kind of projection from information encoded on the universe's boundary, wherever and whatever that boundary is. matter, energy, stars, galaxies, your body, your brain, all of it may be emergent phenomena arising from information fundamentally encoded in fewer dimensions. John Archibald Wheeler captured this with his phrase, "it from bit." Every item of the physical world has at bottom an immaterial source and explanation. All things physical are information theoretic in origin. Matter and energy may be incidental. Information may be what the universe is fundamentally made of. But here's what this means for black holes. When something falls toward a black hole, from an external observer's perspective, it never quite crosses the horizon. Time dilation approaches infinity near the event horizon. The falling object appears to slow down, flatten out, spread across the horizon's surface. Its information smears across the two-dimensional boundary. From the object's perspective, nothing special happens at the horizon. It falls through normally. Both descriptions are valid. This is called black hole complementarity. Different observers see complementary descriptions, neither complete alone. The information is both encoded on the surface and falling through the interior, depending on your perspective. When the black hole evaporates through Hawking radiation, that surface-encoded information radiates away in quantum correlations, scrambled beyond practical recovery, but preserved absolutely. The universe satisfied both general relativity and quantum mechanics by revealing that space itself is more flexible, more holographic, more information theoretic than anyone imagined. This resolution took 50 years because it required reconceiving reality at its most fundamental level. The 2019 calculations involving island formulae and replica wormholes finally showed precisely how information escapes. The mathematics works. The paradox is resolved. Black holes preserve information. So does the rest of the universe. Nothing destroys it. The cosmos keeps perfect records, however scrambled, however inaccessible. Reality's architecture forbids oblivion. And if reality forbids oblivion for books thrown into black holes, what about the information pattern that is you? We've established that information must be preserved, that even black holes eventually return everything they swallow, that the universe's fundamental architecture forbids true erasure. Now, we must confront what this means. The most significant progress since the original paradox came between 2019 and 2021. Two independent research groups, one at Stanford and Berkeley, another at Princeton, derived something called the Page curve using only semi-classical calculations. They didn't need full quantum gravity. They didn't need a complete theory of everything, just careful mathematics and the holographic principle. Don Page had predicted this curve in 1993. As a black hole emits radiation, entanglement entropy should rise, peak at the Page time, roughly halfway through evaporation, then fall back to zero when evaporation completes. This would prove information escapes. The new calculations confirmed it exactly. The mechanism involves what physicists call the island formula, which revealed that after the Page time, certain regions mathematically inside the black hole become part of the radiation's quantum information system. The interior and exterior become quantum mechanically entangled in ways that preserve information whilst appearing to destroy it. The calculations involve replica wormholes, space-time connections between mathematical copies that suggest gravity itself has inherent non-local features. One physicist called it the most exciting development since the original paradox. Another admitted more honestly, we now can compute the Page curve, and I don't know why. The calculations work, the information escapes, but the physical meaning remains mysterious. Physics often gives us the right answers before we fully understand why they're right. The current consensus is clear. Information is preserved. Space-time may be emergent rather than fundamental, and the universe's commitment to perfect record-keeping is absolute. Even in the most extreme circumstances imaginable, matter crushed to infinite density, space-time curved until time itself nearly stops, the cosmos refuses to permit oblivion. This isn't preference. This isn't mercy. This is structure. But preservation and accessibility are different things. When you burn a book, its information survives encoded in ash patterns and smoke trajectories and thermal photons dispersed into the environment. The universe remembers the book perfectly, but accessing that memory requires tracking approximately 10 to the 25th power particles, reversing their interactions, reconstructing correlations destroyed by entropy. Impossible practically, permitted theoretically. Black holes work the same way. Information radiates out through Hawking radiation, but scrambled so thoroughly, encrypted so completely, that recovery is impossible. The scrambling time for a solar mass black hole is approximately 10 to the 70 years. The universe will have expanded into cold darkness long before any practical decryption becomes feasible. Physicists use encryption as an analogy. The information in Hawking radiation is like data encrypted with a password of infinite length. The radiation looks random, combined with the right key, impossible to obtain. The original information could theoretically be recovered, but without the key, the data remains gibberish. One physicist, conceding the point after 30 years of argument, gave his colleague a baseball encyclopedia, joking it was a prize from which information can be retrieved at will. Then added the dark punchline, "Maybe I should just have given him the ashes." The encyclopedia's information survives in ashes, but in chaotically useless form. Preserved, absolutely. Accessible, never. This is how the universe handles everything. Perfect memory, impossible retrieval. The cosmos is in the record-keeping business, not the reminiscing business. Juan Maldacena offered this image. Space-time might be like a lake surface. Insects walk on it, experiencing a well-defined boundary between water and air. But with sufficient magnification, you see molecules in constant motion, no sharp surface at all. What seemed solid and definite at one scale dissolves into quantum fluctuations at another. Space-time could be similar, apparently well-defined, because we're large, but fundamentally emergent from information patterns we cannot directly perceive. We're too big to notice reality's informational substrate. Like fish unaware they swim in water, we move through information space, assuming it's fundamental rather than emergent. The implications cascade beyond astrophysics. If even the universe's most extreme information shredders cannot destroy information, then nothing can. The last theoretical loophole has closed. Oblivion, as far as physics can determine, is not merely difficult. It's impossible. The cosmos simply doesn't work that way. Every configuration of matter that has ever existed remains encoded in the universe's total quantum state. Not organized, not experiencing itself, not accessible, but permanent. The universe has no delete function, only scatter and preserve. And if this is true for books and stars and black holes, what about consciousness? What about the information pattern that generates your subjective experience, your memories, your sense of continuous identity? What about you? The universe doesn't distinguish between types of information. It preserves distinguishability itself. A brain is a physical system. Neurons are quantum systems. Thoughts are information patterns instantiated in matter. If physics forbids information destruction for everything else, why would consciousness be exempt? The question becomes urgent and immediate. When biological processes cease, when neural firing stops, when the organized pattern that generates experience dissolves, what happens to the information? It cannot be destroyed. We've established that. But does its preservation mean anything for what we call you? This is the question we can no longer avoid. Here we must confront something uncomfortable. What you are, physically speaking, is a pattern of information. Not metaphorically, not spiritually, literally, in the precise language of physics. Your consciousness emerges from approximately 10 to the 86th power atoms arranged in specific configurations. Your memories exist as synaptic connection strengths between neurons. Your personality manifests through neurotransmitter patterns, hormone balances, neural firing sequences. The subjective experience of being you, the sensation of continuous identity, the feeling of thoughts arising, the awareness reading these words, all of it corresponds to information patterns instantiated in matter. A brain is a physical system. Neurons are quantum systems. Thoughts are information states. If physics forbids information destruction for everything else in the universe, why would consciousness be exempt? The question isn't whether consciousness is special. Perhaps it is. We don't fully understand how subjective experience emerges from physical processes. The hard problem of consciousness remains genuinely hard. But whatever consciousness is, it operates through physical mechanisms subject to physical laws, and those laws forbid information destruction. Consider what a quantum state actually represents for a complex system like a brain. It's the complete specification of every particle's position, momentum, spin, and quantum correlations with every other particle. For 10 to the 86th power atoms, this is incomprehensibly vast information content. But it's finite, and it's specific, distinguishable from every other possible brain state. When you form a memory, information gets encoded. When you have a thought, quantum states evolve. When you experience consciousness, information patterns organize into configurations that generate subjective awareness. These patterns are physical. They obey quantum mechanics, and quantum mechanics forbids their destruction. This leads to an unavoidable conclusion. When biological processes cease, the information pattern that was you cannot vanish. But now we must be ruthlessly precise about what this means and doesn't mean. Death scrambles information. It doesn't destroy it. When neural activity stops, when chemical processes cease, when the organized complexity that generates consciousness breaks down, the information disperses. The pattern dissolves. But dissolution is not destruction. Think of a sand castle on a beach. You build intricate towers, walls, moats, genuine complexity, temporary stability, meaningful organization. Then the tide returns. Waves scatter sand back into the ocean. The organization dissolves completely. The castle is gone. But the sand remains, and the sand's new configuration carries information about past patterns. The grains redistributed by tides, their current positions, their microscopic interactions, all encode data about the castle's existence. Not usefully, not in any form that allows reconstruction, but the information persists in the universe's quantum state. Your brain's information works the same way. When biological organization fails, molecular bonds break, releasing thermal energy. Tissue decomposes, scattering atoms. Heat radiates away, carrying information in photon correlations. Every molecule that was part of your neural architecture interacts with surroundings, creating quantum entanglements, encoding your previous configuration in relationships among approximately 10 to the 25th power or more particles. The pattern scrambles utterly, but unitarity demands it persists. This is where we must distinguish preservation from survival. These are not the same thing, not even close. When you burn a book, its information survives encoded in ash and smoke. But the book doesn't continue reading itself. The text's information disperses into environmental correlations, but no subjective experience of being a book persists. The pattern exists, the experience doesn't. Similarly, your information pattern dispersing into environmental correlations means the universe remembers you, but you don't remember yourself. For experiential continuity, for consciousness to persist, organization matters. Highly specific organization generating integrated information patterns that create subjective awareness. Scattered information doesn't do that. A computer analogy helps here, though consciousness is presumably more than computation. When a computer's components fail, the information it stored doesn't vanish. It's preserved in the physical states of memory chips, in correlations with heat dissipated into surroundings, in electromagnetic radiation emitted during operation. The universe maintains a perfect record, but the computer doesn't continue computing. The organized activity that constituted its function has ceased. Experience requires organization. Memory requires structured storage. Consciousness requires integrated information processing. Death dissolves the organization whilst preserving the information. This might sound bleak. It's actually extraordinary and stranger than either traditional materialism or religious afterlife suggested. There is no afterlife for broken computers, as one physicist bluntly stated. No heaven for scattered information patterns. No continued experience for dispersed quantum states. The organization that generated consciousness has dissolved. The subjective experience has ended, but neither is there oblivion. The pattern that was, you cannot vanish. It disperses into correlations among particles, encodes itself in thermal radiation, preserves itself in the cosmos's total quantum state, not experiencing this preservation, not organizing into consciousness again, just existing, scattered, encrypted, permanent. The universe remembers you forever. You don't remember yourself. This is the actual situation. Some find this comfortless. Others find it oddly liberating. The universe itself doesn't care about your preference. It continues its perfect information bookkeeping regardless of how you feel about the arrangement. But here's what this understanding does. It reframes the question entirely. Not, do we survive death? But, what does it mean to be temporary organization of permanent information? Not, where do we go? But, what does it mean that the cosmos cannot forget us, even whilst we forget ourselves? The physics doesn't answer these questions. It transforms them. Let's make this immediate and concrete. Notice your breath right now. Each exhalation contains approximately 10 to the 22nd power molecules: oxygen, nitrogen, carbon dioxide, water vapor, trace gases. As you breathe out, these molecules disperse into Earth's atmosphere. Within hours, they've mixed with your room's air. Within days, they've spread through your building. Within weeks, atmospheric circulation distributes them regionally. Within months, they've mixed globally. Someone in Tokyo will breathe molecules you're exhaling now. Someone in Sydney. Someone in Sao Paulo. The information about this precise moment, your thought, your location, your existence right now, spreads across the planet in atmospheric correlations. Watch how thoroughly the universe preserves while scattering. This isn't metaphor. This is thermodynamics and fluid dynamics operating at molecular scale. The specific configuration of molecules in your lungs right now will never repeat. That exact pattern is unique in cosmic history, and its information content disperses into global atmospheric correlations, preserved but practically irretrievable. Smoke from a candle demonstrates the principle beautifully. Light a candle, blow it out, watch the smoke rise. The smoke's intricate patterns, swirls, eddies, dispersal, encode information about the flame's heat distribution, air currents, the room's temperature gradients. As smoke disperses, this information spreads into molecular trajectories throughout the space. The flame's exact configuration is now encoded in where smoke molecules are, how fast they're moving, which air molecules they've collided with. The information about the flame doesn't vanish. It becomes atmospheric background noise. Every transformation you witness operates this way. Ice melting, H2O. Molecules reorganizing from crystalline to liquid structure. Their specific transitions encoding information about the ice's previous shape. Coffee cooling, thermal energy transferring to surroundings via molecular collisions. Each collision preserving information about temperature gradients. A leaf falling. Gravitational potential energy converting to kinetic energy, then dissipating as heat when it hits ground. The leaf's trajectory information preserved in the precise heating pattern of impacted soil. The universe constantly demonstrates information preservation through transformation. We just don't recognize it as preservation because we cannot practically retrieve it. But physics doesn't care about practical retrieval. Physics cares about whether the information exists, whether distinguishable states remain distinguishable. And they do. Always. Your body right now is doing exactly what smoke does, what breath does, what every physical system does, constantly exchanging information with environment. Your skin sheds cells, approximately 30,000 per minute. Each cell carries DNA information encoding your genome. Where do those cells go? Into your clothing, your bed sheets, the air, eventually dust settling everywhere. Forensics can retrieve DNA from decades-old samples. The information persists. Your body radiates heat, approximately 100 watts at rest, like a light bulb. This thermal radiation is infrared photons carrying information about your body's temperature distribution, your metabolic activity, your physical configuration. Those photons travel outward at light speed, bouncing off walls, absorbing into objects, eventually dispersing into the environment. Each photon's frequency and direction encodes data about your body at the moment of emission. You are constantly dispersing information into your surroundings whilst taking in new matter and energy to maintain organization. Life is a pattern that temporarily maintains itself against entropy increase, but only by exporting disorder to its environment. You stay organized by making your surroundings more disordered, breathing out carbon dioxide, radiating heat, excreting waste products. The second law of thermodynamics permits local order increases only through larger environmental disorder increases. Death is when this process stops. The organization dissolves. Entropy increases locally. But information, that disperses into exactly the kind of environmental correlations we've been discussing. Molecular decomposition, thermal radiation, chemical transformations, all preserving information whilst dissolving organization. Think of waves on the ocean. A wave travels across water, visible, measurable, real. But the wave isn't a persistent object. It's a pattern of organization moving through water molecules. The molecules oscillate in place whilst the pattern propagates. When the wave crashes on shore, the pattern dissolves. The energy dissipates as heat and sound. The water remains. Was the wave real? Absolutely. Does it continue after breaking? Not as a wave. The water remembers it passed, in temperature changes, in currents, in beach erosion patterns, but the wave as organised pattern has dissolved. You are similar, a pattern of organisation moving through matter, real whilst organised, dissolved when organisation fails. The matter remembers you pass through it in dispersed information, in environmental correlations, in the cosmic quantum state, but you as experiencing subject have ended. The universe's memory is perfect, but useless for reminiscing. This might seem cold, mechanical, reductive, but consider what it actually means. Every moment of your existence leaves permanent marks on reality's fundamental information structure. Not poetically, physically. The universe's quantum state right now contains information about every thought you've had, every experience you've lived, every configuration your atoms have inhabited. That information will persist after your pattern dissolves, scattered among 10 to the 25th power particles or more. Encrypted by thermodynamic irreversibility, preserved by unitarity, the cosmos will hold the record of your existence forever, even as you cease to experience it. This is neither oblivion nor afterlife. It's something stranger than either tradition imagined, and recognizing it changes how we hold mortality itself. We find ourselves in a rather peculiar situation. We are temporary organizations of matter that physics tells us cannot truly be destroyed. We experience continuity whilst knowing the pattern will eventually scatter. We are, quite literally, the universe examining itself, information arranged into configurations capable of contemplating information. For a brief period, quite remarkable when you think about it, the cosmos has organized some of its atoms into structures that can understand quantum mechanics, prove theorems about information conservation, and wonder what it all means. Then the structures dissolve, and the information rejoins the whole. The question is what we make of this understanding. Does knowing the universe remembers you change how you live? Does recognizing your temporary information organization make existence more or less meaningful? These aren't physics questions, they're questions physics reframes. Consider meaning itself. We often assume meaning requires permanence, that things matter only if they last forever. But symphonies are meaningful whilst they play, though sound waves disperse. Conversations are meaningful whilst they occur, though the patterns dissolve. Experiences are meaningful whilst we have them, though memory eventually fails. A pattern's value isn't determined by eternal persistence, but by its quality whilst organized. You are meaningful now, as this organized pattern contemplating cosmos. That this organization is temporary makes it precious, not pointless. The universe didn't have to arrange atoms into configurations capable of consciousness. That it did, that you exist as experiencing subject, is extraordinary, not diminished by temporariness. The fear of death often stems from imagining total erasure, being deleted completely, as if you never existed. But the universe doesn't permit that. You'll be remembered perfectly, if uselessly, forever. Not experiencing this remembering? True, but neither vanishing into nothing. The anxiety shifts from extinction to transformation, from being erased to being scattered. This is different fear, perhaps smaller fear. You're not facing oblivion. You're facing reorganization into dispersed information. The pattern changes. The information persists. We are, as one physicist noted, just an advanced breed of monkeys on a minor planet of a very average star. But we can understand the universe. That makes us something very special. For brief time, information examines information. Understanding comprehends understanding. The cosmos becomes aware of its own structure. This is rare. This is temporary. This is real. The atoms in your body were forged in stars that exploded billions of years ago. Carbon, nitrogen, oxygen, all manufactured in stellar cores through nuclear fusion, scattered across space by supernovae, eventually collected into planets, incorporated into organisms, organized into you. You are stellar material, temporarily aware of being stellar material. When your organization dissolves, those atoms return to the cosmic cycle. Other organizations will incorporate them. The carbon in your cells might eventually become part of a tree, an ocean organism, another conscious being billions of years hence. The information about you persists whilst the matter continues its journey. The physicist who conceded the information bet after 30 years joked that maybe he should have given his colleague Encyclopedia ashes instead of the encyclopedia itself. The dark humour illuminates truth. Information survives in ashes, but in chaotically useless form. Perfect preservation. Impossible access. This is how the universe handles everything. We want preservation with accessibility, memory we can retrieve, patterns that maintain themselves. The cosmos offers preservation without accessibility, memory perfectly encrypted, patterns that inevitably scatter. Some find this bleak, others find it liberating. The universe doesn't require your approval of its information management policies. But here's what shifts: understanding that death isn't ending or continuing, but transforming. You don't face oblivion, you face reorganization. The experience ends, the information disperses, neither vanishing completely nor persisting as conscious subject. This might make you appreciate the now more intensely. If consciousness is temporary organization of permanent information, then awareness itself is remarkable. Right now, reading this, thinking about these ideas, the universe is temporarily configured to contemplate its own information conservation laws. Pattern examining. Pattern. Information understanding information. When you observe stars, you're seeing stellar material that has organized itself into neural patterns capable of recognizing other stellar material. When you contemplate death, you're experiencing temporary information organization, considering its inevitable scattering. When you understand physics, you're participating in the universe's self-comprehension. This is what we are: brief windows where information organizes into self-awareness before returning to the whole. The universe has been doing this for 13 billion years, organizing matter into increasing complexity, occasionally producing structures conscious enough to contemplate their own temporary nature. Stars form and explode, scattering heavier elements. Planets form, sometimes developing life. Life sometimes develops consciousness. Consciousness sometimes develops physics. Physics reveals that information cannot be destroyed. Space may be emergent. Reality may be holographic. And conscious beings, temporary information patterns, understand all this whilst experiencing their temporary organization. Rather extraordinary that the cosmos produces structures capable of comprehending cosmic structure, but the temporary nature doesn't diminish value, it establishes it. If information patterns lasted forever, each moment would be infinite series with no urgency, no preciousness, no now. Temporariness creates significance. The wave is beautiful because it crashes. The song matters because it ends. Your consciousness is meaningful because it's temporary organization, not permanent fixture. You are experiencing what the universe's information looks like when briefly organized into awareness. This reading moment, this thinking now, this consciousness examining consciousness, these are what permanent information does when temporarily structured into experience. The structure will dissolve. The information will persist. Neither fact cancels the other. The universe doesn't offer eternal life. It doesn't permit oblivion. It offers something stranger, temporary experience of permanent information, brief organization of elements that will reorganize infinitely, consciousness that arises and dissolves whilst atoms continue their cosmic journey. This is the actual situation, and it's rather more interesting than either traditional ending or eternal continuing would be. We've travelled from familiar assumptions about death through black hole information wars to holographic reality, to the physics of consciousness itself. The journey has led to a conclusion stranger than either oblivion or afterlife. You are information that cannot be destroyed, but will inevitably scatter. Let's acknowledge what this means with complete honesty. There is no heaven for broken computers, no afterlife for dissolved patterns, no continuation of experience after organization fails. The universe doesn't owe you eternal consciousness any more than it owes you eternal youth or immortal body. Physics operates without sentiment, preserving information absolutely whilst permitting every possible transformation. When biological processes cease, the organized complexity generating your subjective experience dissolves. The continuity of awareness ends. The sense of being continuous self terminates. Death is real, biological, final in the most important sense. You stop experiencing, but neither is there oblivion. The information pattern that was you, the specific configuration distinguishing your consciousness from every other possible consciousness, cannot vanish. It disperses into correlations among particles, encodes itself in thermal radiation, preserves itself in the universe's quantum state. Not experiencing this preservation, not organizing into consciousness again, just existing, scattered, encrypted, permanent. The universe keeps a record of every configuration that has ever existed. Not organized, not accessible, not useful for reminiscing, but perfect, complete, eternal. The cosmos is quite good at bookkeeping, rather poor at filing systems. This is neither comfort nor despair. This is what physics tells us about information and existence. Black holes prove the principle by being the ultimate test case. If even these cosmic crushers, where matter compresses to infinite density and space-time curves until time nearly stops, cannot destroy information, then nothing can. The 50-year war resolved with physics choosing information conservation over any alternative. Reality itself forbids oblivion whilst guaranteeing eventual scattering. The holographic principle revealed why. Space itself may be emergent from information, not the container holding information. Three-dimensional reality might be projection from two-dimensional encoding. If space emerges from information patterns, then information is more fundamental than the things moving through space. Matter and energy are excitations in information space, not substances that happen to encode information. You are not matter that happens to generate consciousness. You are information that manifests as matter whilst briefly generating consciousness. Wheeler was right. It from bit. Everything physical emerges from information-theoretic origins. The universe is made of information, and occasionally that information organizes into patterns conscious enough to realize this fact. What does this mean for how we live? It means the universe literally cannot forget you. Not metaphorically, physically. Your information pattern is permanently encoded in the cosmos. Every thought you've had, every experience you've lived, every moment of your existence has left indelible marks on reality's quantum state. These marks are scrambled beyond recovery, encrypted beyond decryption, dispersed beyond reconstruction. But they exist. The universe will remember you when you cannot remember yourself. This might not constitute survival in any meaningful sense. Scattered information doesn't experience anything, but it does establish something profound. The cosmos is not in the oblivion business. It's in the preservation business, keeping perfect records of all patterns whilst allowing those patterns to transform infinitely. You persist as information, permanent, scattered, unrecoverable. Whether this matters is not a physics question. Physics simply tells you it's true. But perhaps there's wisdom in recognizing what we actually are. Temporary organizations of atoms that were forged in stars, briefly capable of consciousness, destined to scatter back into the cosmic pool whilst leaving permanent traces in the universe's information structure. Not eternal, not erasable, something in between that neither tradition anticipated. The wave crashes, but the ocean remembers. The song ends, but the sound has travelled. The pattern dissolves, but the information persists. These are physical facts, not poetic metaphors. Look up at the stars. You're made of them, literally, physically, actually. The calcium in your bones was created in stellar explosions. The iron in your blood was forged in supernovae. The oxygen you're breathing was manufactured in dying stars. You are stellar material temporarily organized into consciousness, contemplating stellar material. When your organization dissolves, those atoms return to the cosmos. The information about their temporary configuration persists. Other patterns will incorporate them. The cycle continues, matter organizing, experiencing, dissolving, reorganizing. Information preserved throughout, consciousness arising occasionally, the universe examining itself through temporary structures. This is the situation. Strange, yes, but rather wonderful when you see it clearly. We are patterns in time, briefly organized, destined to scatter into permanent cosmic memory. The universe arranges some of its information into configurations capable of understanding information conservation. Then those configurations dissolve, whilst the understanding they achieved persists in whatever new patterns arise. You are the cosmos's current method of comprehending itself. Temporary method, real method. When you understand that information cannot be destroyed, you're participating in the universe's self-knowledge. When you contemplate mortality, you're experiencing reality, examining its own transformation processes. When you recognize yourself as information pattern, you're achieving the rather remarkable feat of information recognizing itself. This is what consciousness does whilst it lasts. The physicist who spent 30 years arguing about information finally conceded, presenting his colleague Encyclopedia Ashes as prize. The joke revealed profound truth. Information survives in ashes, but in form utterly useless for reading. The encyclopedia's text is preserved completely in the precise arrangement of carbon molecules and scattered smoke particles. Given perfect knowledge and unlimited computational power, you could theoretically reconstruct every word. But practically, the information is lost whilst being perfectly preserved. You will become the universe's encyclopedia ashes, perfectly remembered, impossibly retrievable, neither vanished nor continuing, transformed into permanent cosmic background noise whilst your experiencing of that noise ends. This is neither the ending we feared nor the continuation we hoped for. It's stranger than either, and that strangeness is itself remarkable, that reality should be neither oblivion nor eternity, but information transformation with perfect preservation. The universe remembers you forever, even if you can't remember yourself. That's the actual situation, as far as physics can determine. The cosmos has better information retention than any bureaucracy, and even less practical use for its archives. Every pattern that has ever existed remains encoded in reality's quantum state. Not organized, not experiencing, not retrievable, just there, permanent, scattered, real. We are the universe briefly aware of its own existence, destined to rejoin it whilst leaving permanent marks on its information structure. Temporary patterns, impermanent information, brief experience of eternal cosmic memory. Rather extraordinary that the cosmos should work this way. Rather extraordinary that we can understand it. Rather extraordinary that you exist at all, conscious, questioning, aware that your temporary organization of atoms contemplating their inevitable scattering. The universe has given you brief time as organized information capable of experience. What you do with that time is your choice, not physics. But physics tells you this: you cannot be erased. You will scatter. The information persists. The cosmos never forgets. Look up at the stars and know you came from them. You'll return to them. And in between, right now, you're conscious. That's what information does when temporarily organized into awareness. That's what you are. That's what death transforms. That's what the universe preserves forever, whilst permitting every possible change. The cosmos is not in the oblivion business. It's in the information business. And you are information. Briefly experiencing, inevitably scattering, permanently remembered. Even if you can't remember yourself, the universe remembers you, not sentimentally, not purposefully, just factually, as physical law requires. That's the big misconception about death, that it erases you. It doesn't. It cannot. It transforms your organization whilst preserving your information. Neither ending nor continuing, but something stranger. Something the universe's fundamental architecture makes inevitable. We are patterns in time, real whilst organized, scattered when dissolved, remembered forever in the cosmos's perfect, useless, permanent quantum state.